Top 25 Fiber Optic Technician Interview Questions and Answers. In the competitive field of fiber optics, being well prepared for an interview is crucial for aspiring technicians. This video presents the top 25 interview questions you may encounter, along with detailed answers to help you succeed. Whether you are a seasoned professional or new to the industry, understanding these questions will boost your confidence. Join us as we explore essential topics that can set you apart from other candidates during the interview process. 1. What types of fiber optic cables are you most experienced with? I have extensive experience working with both single-mode and multi-mode fiber optic cables. Single-mode fibers are ideal for long-distance communication, as they allow for higher bandwidth and reduced signal loss over longer distances. Multi-mode fibers, on the other hand, are better suited for shorter distances and are typically used in local area networks. I am also familiar with various cable types, including outdoor-rated cables for harsh environments and indoor cables designed for easier installation in buildings. This diverse experience enables me to select the appropriate cables for specific projects effectively. 2. Can you explain the difference between single-mode and multi-mode fiber cables? Single-mode fiber, SMF, cables have a smaller core diameter, allowing only one mode of light to propagate. This results in lower attenuation and higher bandwidth over long distances, making them suitable for telecommunications and long-haul networks. In contrast, multi-mode fiber, MMF, cables have a larger core, allowing multiple modes of light to travel, which leads to higher dispersion and limits their effective range. MMF is often used for shorter distances such as within buildings or campuses, where high bandwidth is still required, but longer runs are not necessary. 3. Describe the process of splicing fiber optic cables and the tools you typically use. Splicing fiber optic cables involves joining two fiber ends to ensure minimal signal loss. The process starts with preparing the fibers by stripping the protective coating, then cleaving them to create a flat surface for a precise connection. There are two primary splicing methods, fusion splicing and mechanical splicing. Fusion splicing uses an electric arc to melt the fibers together, while mechanical splicing aligns and holds them without melting. Common tools include a fiber cleaver, fusion splicer, optical power meter, and a microscope for inspecting the splice quality. Proper technique and equipment are essential for successful splicing. 4. What makes fiber optic cable superior to other types of cable? Fiber optic cables excel in speed, bandwidth, and distance capabilities. They transmit data using light signals, allowing for incredibly high data rates compared to traditional copper cables. This results in faster internet connections and reduced latency. Additionally, fiber cables are less susceptible to electromagnetic interference, making them more reliable in environments with heavy electronic noise. Their lightweight and flexible nature also simplifies installation and routing. Finally, fiber optic cables are more durable and have a longer lifespan, reducing maintenance costs and improving long-term network performance. 5. Which testing methods do you use for verifying fiber optic network integrity? For verifying fiber optic network integrity, I typically use several testing methods. First, I conduct an OTDR, optical time domain reflectometer, test, which helps identify faults, splices, and bends along the fiber. I also perform insertion loss testing using a power meter and light source to ensure that signal loss is within acceptable limits. Visual fault locators are employed for quick troubleshooting, enabling me to pinpoint breaks or bends. Finally, continuity testing checks signal presence along the fiber, ensuring a complete pathway for data transmission. 6. Can you describe a challenging fiber optic installation you worked on and how you overcame the difficulties? One particularly challenging installation involved running fiber optic cables in a historic building with tight spaces and existing infrastructure. The primary difficulty was avoiding damage to the original architecture while ensuring optimal cable routing. I conducted a thorough site assessment and collaborated with the building's management to devise a plan. We used specialized tools to carefully maneuver cables through small openings and employed protective measures to prevent any harm. This careful planning and execution enabled a successful installation while preserving the building's integrity. 7. What steps do you follow when installing fiber optic cables in a commercial building? When installing fiber optic cables in a commercial building, I start by conducting a site survey to determine the best routing paths and identify any potential obstacles. Next, I plan the installation by mapping out the cable runs, ensuring compliance with local codes and regulations. After gathering the necessary tools and materials, I prepare the cables by stripping and terminating them as needed. During the installation, I secure the cables using appropriate conduits and supports, ensuring minimal strain on the fibers. Finally, I test the connections for integrity and performance before closing the project, documenting all steps for future reference. 8. How do you perform maintenance on fiber optic equipment and tools to ensure optimal performance? Regular maintenance of fiber optic equipment and tools involves several key steps. First, I ensure that all tools are cleaned after each use, removing any dust or contaminants that could affect their performance. I conduct routine inspections of splicing machines, test equipment, and connectors, checking for any signs of wear or damage. Calibration of testing equipment is performed periodically to maintain accuracy. Additionally, I keep a log of maintenance activities and schedule preventative maintenance to address potential issues before they become critical, ensuring reliability and longevity of equipment. 9. What experience do you have with terminating fiber optic connectors? Terminating fiber optic connectors involves several essential steps. Initially, I prepare the fiber by stripping the protective coating and cleaning the exposed fiber with alcohol. Next, I cleave the fiber at a precise angle to ensure optimal light transmission. Using a fusion splicer or a mechanical splice, I attach the connector to the fiber, ensuring that it is aligned correctly. I then test the connection using an optical power meter to confirm signal strength and quality. This meticulous process is crucial for achieving reliable performance in fiber optic networks. 10. How do you handle unexpected challenges during a fiber optic installation project? Handling unexpected challenges during a fiber optic installation project requires a methodical approach. First, I assess the situation to understand the specific issue, whether it's a delay in material delivery, unforeseen site conditions, or technical difficulties. Communication is key. I keep all stakeholders informed about changes. I then adapt our strategy, which may involve reallocating resources or adjusting timelines. Collaborating with the team helps identify alternative solutions quickly. Maintaining flexibility and a positive attitude is crucial to navigating these challenges effectively. 11. How do you troubleshoot a fiber optic network? Troubleshooting a fiber optic network involves several systematic steps. First, I check the optical power levels using a power meter to identify any signal loss. Next, I inspect connectors and splices for dirt or damage, as these can greatly affect performance. Utilizing an OTDR, optical time domain reflectometer, I can pinpoint faults along the cable length, allowing for efficient repairs. I also examine the network configuration and test individual segments to isolate the problem. Communication with team members is crucial during this process to ensure that all aspects are considered and addressed promptly. 12. Describe a time you diagnosed and fixed an issue in a fiber optic system. In a recent project, I encountered a problem with a fiber optic link that was intermittently dropping connections. I started by using an optical time domain reflectometer, OTDR, to pinpoint where the signal loss was occurring. Upon inspection, I found a damaged splice point that was causing the issue. I carefully re-spliced the fibers using a fusion splicer and tested the connection again. After confirming the integrity with a power meter, the issue was resolved, and the network stabilized. This experience reinforced the importance of thorough diagnostics and attention to detail in fiber optic maintenance. 13. What tools do you use for pinpointing cable faults? When pinpointing cable faults, I utilize a range of specialized tools. One of the primary tools is an optical time domain reflectometer, OTDR, which helps in identifying the exact location of faults by sending light pulses through the fiber and analyzing the backscattered light. Additionally, I often use visual fault locators, VFLs, for quick checks, as they can easily indicate breaks or severe bends by shining a bright light through the fiber. Fusion splicers equipped with advanced features also assist in ensuring that any splices made are optimal. Together, these tools allow for efficient fault detection and resolution. 14. How do you ensure minimal downtime during network repairs? To ensure minimal downtime during network repairs, I prioritize thorough planning and preparation. This includes conducting a detailed assessment of the network to identify the most critical components that require attention. I maintain an inventory of essential spare parts and tools, allowing for quick replacements. Communication with clients and team members is vital. I provide regular updates throughout the repair process. Additionally, I often schedule repairs during off-peak hours to minimize the impact on users. Implementing redundancy in the network design also helps maintain service continuity during maintenance activities. 15. What is the most challenging part of being a fiber optic technician? The most challenging part of being a fiber optic technician often involves troubleshooting complex issues that arise during installations or maintenance. Each project can present unique obstacles, such as navigating tight spaces, coordinating with other contractors, or ensuring minimal disruption to existing services. Technicians must also stay updated with rapidly evolving technologies and standards, which requires ongoing education and training. Balancing technical skills with effective communication, especially when interacting with clients or team members who may not have a technical background, can also pose significant challenges. 16. How do you ensure quality control during fiber optic installations? Quality control during fiber optic installations is achieved through meticulous planning and execution. I start by reviewing project specifications and using standardized procedures for installation. Each step, from cable handling to termination, follows industry best practices. Regular inspections are conducted at critical stages, using tools like optical time domain reflectometers, OTDR, to verify signal integrity. Additionally, I maintain detailed documentation of tests and results, enabling traceability and accountability. Team training on quality standards further boosts adherence and reduces errors in the installation process. 17. What safety protocols do you follow when handling fiber optic cables? When handling fiber optic cables, I prioritize personal safety and the integrity of the cables. First, I always wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. I ensure that work areas are clean and free of hazards to prevent accidents. Additionally, I follow proper cable handling techniques, avoiding excessive bending or pulling. I also use appropriate tools designed for fiber optic work, ensuring they are in good condition. Regular training on safety standards and protocols helps keep me updated on best practices, ensuring a safe working environment. 18. How do you stay updated on industry standards and regulations related to fiber optics? Staying updated on industry standards and regulations related to fiber optics involves several proactive steps. I regularly participate in professional organizations and attend industry conferences, which provide valuable insights into emerging trends and changes in standards. Subscribing to reputable industry publications and online resources keeps me informed about new technologies and best practices. Additionally, engaging with peers and experts through forums and social media platforms allows for knowledge sharing. Continuous education through certifications and training programs also plays a crucial role in maintaining my expertise in fiber optics. 19. Describe a situation where you implemented a safety solution in a fiber optic project. In a recent fiber optic installation project, we encountered a scenario where technicians were working in an area with high foot traffic. To mitigate the risk of accidents, I proposed the use of brightly colored safety barriers and cones to delineate the work zone. Additionally, we implemented a system of clear signage to inform passers-by about the ongoing work and potential hazards. Regular safety briefings were conducted to ensure all team members understood the importance of adhering to safety protocols. This proactive approach resulted in a safe working environment and minimized disruptions. 20. What measures do you take to prevent contamination or damage to fiber optic ends? To prevent contamination or damage to fiber optic ends, I follow strict handling protocols. First, I ensure that all connectors and fiber ends are kept capped and covered until ready for use. During installation, I avoid touching the ends with my fingers and use lint-free wipes for cleaning any dust or debris. I also maintain a clean workspace, using anti-static mats and appropriate storage for tools. Additionally, I use protective cases for transporting connectors and inspect them regularly for scratches or defects, addressing any issues immediately to ensure optimal performance. 21. What is the purpose of a fiber distribution hub in a fiber-to-the-home (FTTH) network? A fiber distribution hub plays a crucial role in a fiber-to-the-home (FTTH) network. It serves as a central point for managing and distributing fiber optic signals from the main network to individual homes. The hub helps to organize fiber connections, ensuring efficient signal routing and minimizing signal loss. It typically houses splitters, which divide the optical signal for multiple endpoints, and also provides a secure location for fiber splicing and terminations. By enabling scalability and easy maintenance, the fiber distribution hub enhances network reliability and performance for end users. 22. How do you communicate technical details of fiber optic projects to non-technical clients or team members? Communicating technical details of fiber optic projects to non-technical clients or team members requires clarity and simplicity. I focus on using layman's terms, avoiding jargon, and breaking down complex concepts into manageable parts. Visual aids, such as diagrams or charts, can help illustrate ideas effectively. I also encourage questions to ensure understanding. By relating the project's impact to their needs and objectives, I create a more engaging dialogue. Active listening plays a crucial role in gauging their comprehension and adjusting my explanations accordingly. 23. What is your experience with client requirements and documentation in fiber optic projects? In my roles, I have collaborated closely with clients to understand their specific needs and expectations for fiber optic projects. This includes gathering detailed requirements to ensure alignment with their goals. I maintain comprehensive documentation throughout the project lifecycle, covering everything from initial assessments and design plans to installation steps and test results. This documentation serves as a vital reference for both the client and the project team, facilitating clear communication and ensuring all parties are informed about progress and compliance with specifications. Regular updates and feedback sessions help to address any concerns promptly. 24. What components of a fiber optic system do you have the most experience with? I have extensive experience with various components of a fiber optic system, particularly fiber optic cables, connectors, and splicing equipment. My proficiency includes working with single-mode and multi-mode cables, understanding their applications and benefits. I am skilled in terminating connectors, ensuring optimal signal transmission. Additionally, I have hands-on experience with optical distribution frames and patch panels, which are crucial for organizing and managing connections. My familiarity with testing equipment, such as OTDRs, optical time domain reflectometers, allows for effective troubleshooting and maintenance of systems. 25. Can you explain the difference between FTTC, fiber to the curb, and FTTH, fiber to the home? FTTC, or fiber to the curb, delivers fiber optic connections from the main distribution point to a curbside cabinet. From this cabinet, the final connection to homes is typically made using copper cables, such as DSL or coaxial, which can limit speeds compared to a fully fiber optic solution. In contrast, FTTH provides a direct fiber connection from the service provider straight to the home, facilitating higher bandwidth and faster internet speeds. FTTH is often preferred for its superior performance in data transmission, reliability, and future-proofing against increasing bandwidth demands. In this video, we've explored the top 25 fiber optic technician interview questions and answers to help you prepare effectively for your next job opportunity. Understanding these key topics will not only boost your confidence but also enhance your technical knowledge, making you a strong candidate in the fiber optic industry. We hope you found this information valuable and that it aids you in your career journey. If you enjoyed the content, please give us a thumbs up and subscribe to our channel for more helpful videos. Thank you for watching.